In this video, we're going to do a brief overview of graphing linear equations. This should be a review for most of you, and this is something we are going to go further in throughout this first unit. So when we're graphing linear equations, we deal primarily with two forms. The first form of the equation is slope-intercept. And what that slope-intercept form is saying is it's y equals mx plus b. Many of you should be familiar with this. That first m is the variable for slope, and the b is the variable for the y-intercept. Throughout this unit, you're going to hear the slope called rate of change, and the y-intercept called the initial value. So let's look at an example. If we're asked to graph the equation y equals 1/2 x plus 7. In this equation, the 1/2 represents our slope, and the 7 represents our y-intercept. That y-intercept is essentially telling us where the line intercepts or crosses the y-axis. That's why it's extremely important to make sure you always label your axes. So we are going to plot a point on the y-axis at 7. And then from that point, we're going to fill in the rest of our coordinates on the line using the slope. Remember, slope, rise over run. We're going to rise 1 and run 2. Rise 1, run 2. Notice how I've run out of room on my graph, so I need to go in the opposite direction. That opposite direction is still rise over run, but reversed. So I'm going to go down 1 and to the left 2, and notice my coordinates stay in sync in that line. In order to graph, we want to make sure we're using a ruler, and we essentially just connect our points, add arrows because lines go on forever, and we've graphed our line. Notice our slope is positive. It's going in an increasing direction. When our slope is negative, it'll be going in a decreasing direction. Just something to remember, a review. So now let's look at the next form of a linear equation. Standard form. And the standard form is ax plus by equals c, where a, b, and c are all integers. There are two ways to graph the standard form of a line. The first way is to solve for y so that we're given the slope-intercept form. So the example of negative 2x minus 3y equals 9. I want to solve for y. I'm going to go about this using our properties of equality we learned in a previous video. If I'm solving for y, I want it by itself, so I'm going to use the addition property and add 2x on both sides. My 2x's cancel out, and I'm left with a negative 3y equals 9 plus 2x. In order to get y by itself, I need to use the division property of equality, and I'm going to divide both sides by negative 3, which leaves me with y equals 9 divided by negative 3 is a negative 3, and then a negative 2/3. It is perfectly fine to leave the variable or the coefficients in terms of fractions. So now we're graphing this just like we did the previous. where our y-intercept is -3, and our slope is a -2/3, so I'm going in that decreasing or negative direction. I'm going to go down 2, 1, 2, and to the right 3, 1, 2, 3. 1, 2, 1, 2, 3. And take our ruler. Draw arrows, and we have our line. The second way to solve for the to graph standard form equations is to solve for the intercepts. And what that's saying is we want to know where our line crosses the y-axis and where our line crosses the x-axis. So if we look at the example, 3x plus 4y equals 12. In order to find our intercepts, we'll start with our y-intercept. Our y-intercept is where x equals 0. So we substitute 0 for the value of x in our equation and solve for y. 3 times 0 gives us 0, so we're left with 4y equals 12. Use the division property of equality, and we're left with y equals 3. So our y-intercept is when x is 0, y is 3. So we can plot that coordinate. 0 and then 3. The next intercept is the x-intercept, and that's when y is equal to 0. So once again, I'm going to substitute 0 for the value of y, and now I'm going to solve for x. 4 times 0 is 0, so I'm left with 3x equals 12, division property of equality, and I'm left with x equals 4. So when y is 0, x is 4, we can plot this coordinate at 0, 2, 3, 4. And now take our ruler and connect our intercepts with a line, and you have our equation, our linear graph of the equation. We're going to be using this throughout the rest of this unit and throughout this course, solving and modeling mathematics.